All right, so good afternoon, everyone. We are now talking about ratios and rates, and please go ahead and check on your notes regarding such. All right, so when we say ratios and rates, our objective are the following: to what? Solve application problems involving ratios and rates. So let's consider first how do we answer these questions in here. So typically for word problems, we're gonna consider a deeper understanding of those word problems using what we call the cubes method. Okay, so what is that cubes method? Well, first we're gonna circle. What do we need to circle in a word problem? Okay.
Circle a given number.
Thank you. Circle given numbers. Okay. So whatever the given numbers are, we're gonna circle them because those are important in solving our making an equation and solving our numerical values. What do we need to underline? Okay. Jonathan. Myers. Yes. What is being asked? Certainly, you want to know first what you are solving. Right? And that's mostly important, right? Get it? Okay. What do we need to solve again? Well, you better know what we're solving, right? Next, we need to box what? What do we need to box in here? Jenna.
Keywords and phrases.
Thank you, right? So typically these keywords and phrases are the ones that are relate to the values, okay? So typically they're either before the given value or number or after the given value or number, okay? So these are what we call the important keywords. And in some cases, not just a word, but a phrase, okay? And after that, what do we do then? What is E? This is where our math skills is gonna work, well, should work already, okay? River, yeah.
Create an equation.
Yes, okay. So we better create an equation for that, right? And how do we know it's an equation? Well, we know if it's an equation if you have an equal sign. Okay, so again, it cannot be an equation if you don't have an equal sign. Okay, and the last one is certainly to practice your math skills. Blaze, what is that?
As solve.
Solve, right? Solve what you are being asked to solve for, right? So that's our cubes. Circle the numbers, underline what you need to solve for. B, okay, typically what those numbers mean, okay? E, you create your own equation, so you should know whether you add, divide, multiply, subtract, okay? Or a combination of those, what we call order of operations, PEMDAS, right? Parenthesis, exponent, multiply, divide, which can interchange, add, subtract, which also can interchange, right? Whichever goes first. And then after that is your solution, okay? So let's practice this given an example for such. So here is how to let's read this particular example in here about what we call ratio. Okay, so let's read this ratio question in here. Mary, go ahead, please. Write the ratio. Can you see it from there? Sorry. Okay, yeah. All right, go ahead, please. Can you see it from there?
1,200.
Write the ratio first. Okay, you cannot see it from
Oh,
there. Okay.
simplest form. Sorry.
In simplest form. Using what? Fraction. So typically when you have ratio, you would typically have a fraction where there's a numerator and there's a denominator, okay? And again, when you say simplest form, that means the numerator and denominator are what we call relatively prime numbers. What are those? What we mean by relatively prime numbers? That means they don't have what we call a any common factor anymore, right? They don't have any GCF anymore, right? That means, yeah, they're relatively prime. They're not necessarily prime, but relatively prime. You get? Okay. Meaning they don't have they don't share a common factor or GCF among themselves. So let's do this. Use the table to find the ratio of what? Housing cost to total expenses. So the housing cost is 1,200 and the total expenses is 4,800. Okay, so we circle those given numbers. That's what we need. We underline what the question is. What do we need to find? Ratio. Not percentage, not decimal. It says what? Ratio. Okay, so find the ratio. That's what we need to do. Box the keywords. Okay, so what is the 1,200? That is the housing cost. Okay, we box that. And what is the 4,800? That's the total expenses. Got it? After that, we're gonna make our equation already. So this is what? What are we missing in here? So actually, we're missing in here the equation, and this is the equation. This is the what? The ratio, right? Okay, so what's your equation now? Well, the ratio is equal to what? Well, that's the housing cost over the total expenses, all right? So that's 1,200 divided by 4,800. After that, how to simplify a fraction. Let's see how do we simplify that one, okay? Let's read these steps in here. Steps 1, 2, and 3, okay? Let's read the first one. Brandon is already here? Not yet? Okay. Caitlin.
What do you want me to do?
Step number 1.
Oh, find the greatest common factor.
Between?
Numerator and denominator.
Thank you. Okay, and again, our calculator, Desmos calculator, can in fact give us the GCF, greatest common factor. So go ahead, guys, open your Desmos calculator, and let's do this, okay? We're finding the GCF between 1,200 and 4,800. So click on your Desmos. Everyone already there? Okay, let's do it. How to get the GCF? So here it is. Click on
1/4.
this one. Okay. And we're gonna see that one first as well, okay? The result. We're gonna click on functions. Okay. Now under functions, where's the GCF? We go under the group of numbers or number theory. Okay, so let's go down, see where that one is, okay?
It's at the very bottom.
Very bottom, yeah, thank you. So you see that number theory? Where's that GCF? That's the greatest common divisor. Okay, you see that D? That's the divisor, okay? The LCM now, however, is the least common multiple. Okay, so these are embedded functions or tools in your Desmos already, and you can definitely use those. However, just be aware that this only considers the GCF and LCM of 2 numbers at a time. Okay, so if you have 3 numbers, what you're gonna do? You get the GCF first of the first 2, and then whatever the GCF is, you get its GCF of the third. Okay, so again, this is pairwise only. So if you have 3 or more, what do? Get per 2, right? Get the first 2 GCF, and whatever that value is, get its GCF with a third, and so on. Get what I mean? Okay, so anyway, how do we do this? Click on GCD. After that, put in your 2 numbers. What are those 2 numbers again that we say? 1,200 and what? 4,800. So as you may notice in here, in fact, the greatest common factor between those 2 numbers is how much? Thank you, 1,200, which means those 2 numbers can equally be divided by 1,200. Okay, so let's see. What do you mean by that? So that means what? The first number, 1,200, if you divide it by 1,200, is 1. And the other one, 4,800, divided by another, the GCF, 1,200, 4. That means you're gonna get a whole number as a what we call quotient. We get that means it will equally divide those two numbers. Okay, got it. Okay. So anyway, going back. Okay. So again, find the GCF of those. So that means 1200 divided by 1200 is 1. 4800 divided by 1200 is 4. Okay, so that's what we mean by step number 2. And let's read the step number 2. What did it say for us in there? Okay, Drew. Drew Hunt is already here. Yes, Drew. Yeah. What you got? Factor out.
Factor out GCF.
Thank you, right? So when you say factor out that GCF, so again, the GCF is 1200, right? 1200 divided by 1200 is 1. Excuse me, 4800 divided by 1200 is 4. You already factored out the GCF. Now after that, what do we do? Step number 3. If you have common factors up and down, what do you need to do? Okay, step number 3. Okay, Trinity. Cancel the GCF. So since again you have 1200 up and down, you just cancel them. In short, just 1 4. Okay. And again, someone told us, well, you can basically just simplify it just really quick. Honestly, if you put in here what 1200 divided by 4800, then it's gonna give you what?
4, right? You press the fraction.
Yeah. But you pressed very good. You see this blue icon? That's gonna give you the ratio because your ratio is always gonna be in fraction form. Get it? Okay. Okay. So again, either we do this, what we mean by that is step by step, or you just quickly put it in your calculator like that. Okay. Since everything will be in decimal, just click on that, it will be a fraction. Okay. Questions? So the answer is basically 1 4 as a ratio. Okay. All right. We still have some more in here. What's that last step? What's the last step in here? Step number 4. Make sure that the numerator and denominator are relatively prime. So you see that 1/4, okay? 1 is a prime number, but 4 is not prime. However, they don't have any common factor anymore, the 1 and the 4. Questions?
So it not having a common factor is what makes it relatively prime?
Yes, very good, right? So when you say relatively prime, they're not technically prime numbers, but they are prime relative to each other. Get it?
Okay.
Yeah. When you say relatively prime, that means even if they're not an actual prime number, like 1 or 2 or 7 or 11 or 13, okay, but if they don't have a common factor with the next number, then that means relatively they're prime to each other.
So how does that change our definition of a prime number?
Oh, okay. So the definition of a prime number is what? Well, a prime number is what? A number that only has 1 and itself as a factor, right? Good. No other common factor, right? However, a relatively prime number is what? Well, certainly these are what? At least 2 numbers, right? You cannot have just a 1 relatively prime number, right? Because when you say relatively prime, that means this prime number, well, these 2 numbers are what? Even if they're not prime, they don't share any common factor with each other. Okay. Even if they're not prime. Okay. So regardless of them being prime or not, it doesn't matter. Okay. As long as they don't share any common factor. Get it? Question. And by definition, how do you know if 2 numbers are relatively prime? You get the GCD of these 2 numbers. If their GCD is always 1, then that means they're relatively prime numbers. We get? Let us continue, guys. So here it is, and let me it was just cut, but let me just share with you what the problem is. It says in here, which is more economical, which is a more economical purchase, meaning which one is cheaper? A mayonnaise, 36 ounce jar of mayonnaise for $4.39, or a 42 ounce jar of a different kind of mayonnaise at $6.39. So which among those is more economical to buy? And how do we know that? What do you do? Okay. What do we do in here? Okay, so as we may notice in here, we circle the numbers first. The first mayonnaise is 36 ounce. And the cost is how much? $4.39. Okay, let's call that the mayonnaise 1 or mayonnaise A. The second mayonnaise is what? In a 42 ounce jar, and it costs $6.39. Okay, so with that being said, we underline what we need to do. What do we need to do? To know which one is the most economical purchase. Okay, so box the keywords. The 36 is the volume, right? By the way, when you say ounce, that's the volume, right? That's how big of a jar it is, okay? And the $4.39 is the value, okay, or price. So same in here, that ounce is a volume, how big of a jar it is, and that $6.39 is the price as well, okay? So how do we make an equation? What are we trying to solve in here? When you are dividing $4.39 with a 36 ounce jar, what are you getting? What is this? Anyone who can tell us what this one means? This is called the what?
Oh, unit price?
Yes. Anyone who's been grocery shopping? Yes, yes. What do you notice on the labels, right?
Price.
You're gonna get the price, but on the small, it's kind of like a small area in there. It's gonna tell you the unit price. In short, how much are you paying per what? Per pound, per ounce, per grams, per inch, or whatever it is, the unit measurement for that. Okay. And by the way, that's our next topic, measurement. Okay. Good. So the unit price for A is what? Well, you're buying $4.39 on a 36 ounce jar. So basically, it's how much? You're buying what? 12 cents per ounce. Okay? Again, that's the unit price. How much does it cost per unit? Okay? That means per ounce. You're getting that at 12 cents per ounce. Okay? Mayonnaise 2, we're going to do the same. So what is that? What do we need to do to get the unit price for mayonnaise 2?
Divide the price of...
Divide. What's the price again?
$6.39.
Very good, right? Yeah. You divide $6.39 by
42.
the volume, which is 42 ounce. Okay. Oh, yeah. So, can you divide this on your end? So again, you certainly need to use your decimals calculator for that. What's $6.39 divided by 42 ounce? Okay. Anyone who gave us the answer? Yes, go ahead. 0.15 cents. All right. So it says in here $6.39. Is that 6.39? Right. Divided by what? How much? 42.
Yeah.
0.15 as well, okay? Honestly, this is like 0.152 or something, right? But since we're talking about money, money is valuable until the last what?
Cent.
Penny or cent, okay? So that's why, because you might be asking, Mr. Deal, why not 0.152, 0.15214 and everything else? Well, the thing is, if you're talking about money, you're basing it up to the last penny, okay, which is what? 0.15. Okay, so with that, let's put it in here like such. 0.15. Well, if I see it in here. Oh, there we go. Oh, there it is. Okay, 0.15. Okay, per oops, ounce. Okay, so according to that one, that's another value for or importance of what we call ratios, okay, or rates, okay. D1, unit price, okay. So which one is more economical to use or to buy? The 36-ounce jar of mayonnaise, okay. Again, we are just talking about it being economical by volume, right? But regardless of some other factors, like what? What are other factors affecting your purchase?
Taxes.
Taxes, what else?
Budget.
Budget, what else? What quality of the product that you're buying, right? This might be a cheaper brand, but if it's like, okay, I'm gonna put in some brands. If it's like a Miracle Whip, I'm not gonna buy it.
I need even mayonnaise. What are you talking about?
Only.
See that? That's what I mean. Like, we're just okay. Sorry for that. Anyway, Mr. Did just mention some brands. Anyway, huh? It will be a miracle if I'm gonna taste it even, right? But you know, we are just talking about the economical by volume, right? But we're not talking about what? Even the quality or even the just the preference of the product itself. Okay. Any questions? Any questions? Okay. Can you tell me something about, like, say, a brand or something that you don't care how much it is, you're still gonna buy it anyways?
Yeah.
Like what? Go ahead. M&M's. Okay. What else?
Like,
It doesn't matter, this brand, it doesn't matter if there are some other choices, doesn't matter if it's
chips,
more expensive than the rest, but you're still gonna buy that brand anyways.
ice cream.
Like what
Oh
brand?
yeah, Tillamook ice cream.
What ice cream?
Yeah, Tillamook.
Tillamook. Okay.
So good. Oh my god.
So that's what I mean.
Haagen-Dazs.
We're just saying that it's economical by volume, but the quality or your own preference, it matters as well. Okay? We good? Questions? Got it. Any other stories or anecdotes regarding these ratios and rates? Okay. One last example before we go to our website homework, guys. And honestly, our amplified task as well. We have an amplified task for this, guys. Okay? Ooh, okay. The what?
Mr. Pig.
Mr. Pig. What's that?
Pib.
A pib.
It's
Is that a...
It's like Dr. Pepper.
No, it's not.
Oh.
It's its own
Actually
thing.
good.
It's its own thing.
Okay, then what's not?
It wants to be
No,
Dr.
Mr.
Pepper
Pig is
so bad.
Mr. Pig is cherry flavored.
It's
So
like
it's,
spicy cherry.
so it's like
That's
cherry
what
wine,
Dr. Pepper.
comparable cherry wine or
No, it's
something?
not.
Oh, absolutely not. That
Oh,
compares
no.
to Cherry Wine and Dr. Pepper.
Okay, I'm done.
Okay.
I'm gonna crush out.
All right. Listen, guys. We're now gonna talk about, yes.
Is there a way you can like clear the screen of like how you have already writing all there? Is there a way you can like clear it off so we can?
If I do that, then I'm gonna erase everything.
Okay.
Yeah. Sorry. Okay. So let's do this one in here. Okay. We're now talking about what? Not only population, but population density, okay? Because first of all, by rank, okay, by population, okay, what's our rank? United States, okay? Can you check it on your end? What's the rank of the United States in terms of population?
Oh, okay.
Okay, go ahead. I'm gonna use my Meta as well. Hey Meta, what's USA's rank in terms of population?
Yes, it is.
Third. Third place. Based on one source. I don't know. I didn't.
Thank you. So it says India is number 1, China is number 2, and we are number 3 with 300, how much? 300 something million.
Yes. something
So
like that.
India 1, China 2, us 3. But let's now talk about population density, okay? Can you check it out? Population density, what's our rank? Go ahead, check it out.
What's our what?
Population density, what's our rank? We are in by population the third, but in terms of population density, where we are. Okay, check it out on your devices. I'm gonna check on my AI as well. Hey Meta, what's USA's rank in population density?
149.
26?
26?
What? What is wrong with mine?
Was it like an AI result?
Everything's in the
We are rank what? 100 what?
Mine says 149 for global.
186 or something, 149 globally in terms of population density. Why? Even if we are third by population, we are a big country
I mean, if
by
you ignore
land
the
mass.
projector,
And with
we're
that being
massive.
said, huh?
If you ignore the Mercator projector, we're massive.
Yes.
Well-
Yes, yes, yes.
Well, okay. You put it like that.
Okay.
It's true.
So you get it? Okay. We are third by population, but with our big mass, land area, we are what? Way below. Like what's that? 100 what?
149.
We are 149th.
It says roughly 38 people per square kilometer.
38 people per square kilometer. Imagine that.
Or 98 per square mile.
Per square mile, there are only what? Not even or barely even 100
Yes,
people
98.
per square mile. See? That's how population density is, okay? So even if we're third in population, we are way down in terms of density. Why? Because we have way bigger land mass. Let's now read this one. And how do we do this? Let's read it first, okay? Volunteer, read this one. Okay, just reading it. Go ahead. Thank you.
Suppose the following table shows the population and area of 3 countries. The population density, it cuts off, of a country is the number of people per square mile.
Thank you. So mine is basically an English unit for what? When you say square mile, that is what? An English unit for area. Okay. If it's just mile, then that's for distance or length. Okay. But since this is square mile, 1 mile here, 1 mile there, then that's an area. Okay. So, country A has what? 15,879,000 over 2.928. That's 2,928,000. And basically from there, it's basically just what? 5 people per square mile. Okay? 5 people per square mile. Can you check on country B? And you might be thinking, why are we doing that? Because in here, letter A, let's read what is being asked. Eric is in here. Eric? Oh yeah, go ahead, Eric.
What?
Which country?
I don't have to.
And then what's your question?
Letter A, right? What is being asked for letter A? Which country? Or do you have it in there, guys?
Which country has the lowest population density?
Density. Thank you. Okay. So not really the lowest population, because if it's the lowest population, that's country A that has the lowest population. But we're talking about population density. Okay, and how do we do that? We divide the population by the square area. Okay, in square miles. Okay. Can you give us what's the population density for country B? Again, we're talking about people, that's why we're rounding down to whole numbers, okay? So 5.4, it's 5. Anyone can do country B. What's the population density for country B?
1,158 or 59.
So you got this one to be how much?
1,158. This is 0.5.
0.5, right?
So
Mm, $1,158.5.
8. Yeah.
Okay. So in here it says always what? To round down to whole numbers. So even if it's 0.5,
Just 1,000.
1158. Okay. I'm still just gonna use the 1158. People per square mile. Okay, and how do we do that? Well, you divide this by that. Okay, check it in your end. What's 1316093 divided by 1136? Okay, what's that? 1316093, right? Put it in here. 1316093 divided by 1136. And as you may notice in there, the 3 zeros in here and the 3 zeros in there, I just cancel them out, okay? Because they're basically what? The common factor is 1,000, okay? So and then after that, it's what? 1158 people per square mile,
I would
okay?
go crazy living there. That's way too many people.
As compared to the first one is just how much? Just 5 people per square mile. But this one is what? 1158 people.
9, because you round up, right?
Well,
It says round
since
down.
this is people, you always round down, okay? So statistically, if you say 0.5, that means what? By statistics, you round up because what? 0.5 and up, you round up. But since this is people, these are people, you always just round down, okay? Get. And the last one, what's the last one? It's the population density for the third one, guys, okay?
90.
90.
Did you get 90?
Yeah,
Yeah.
90.
Okay. 90 or 91?
90.
90.
It's 90.6, but you round
90.6, so you round down, right? Square mile. Okay, so with that being said, so country A has the least number of people, which is how much is this? 5 people per square mile. Okay. What's the next? Country C. Okay, so this is A. Country C has how much?
90.
90 people per square mile. By the way, I'm just doing some abbreviations in here by people, PPL. Mile, square mile. This can also be the case. Either this or that. Those are square. And the one with the highest population density is country B. Okay, which is what?
What are the population density here is?
1158 people per square mile. So with that being said, then country A. What about letter B? Let's read letter B in here. Okay, well, let me read it for you guys. How many more people per square mile are there in country B than in country C? So what do you do? What's that? How many more people per square mile are there in country B than in country C? Round to the nearest whole number. So what do you do with these two?
Divide them.
When you say how many more people, you what? Subtraction. Okay, so basically in here, they should be what? 1158, oops, minus 9.
I'm looking 68. Okay, that's already 1,060.
1,060.
That's
Okay.
already right there.
Yeah. Okay. So basically, we're just answering what's the reasoning behind the 1,068. It's basically when you say how many more density from this to that, then you subtract. Okay. Questions regarding that? So again, those are our rates and ratios. As you may notice, the rates and ratios can be seen in terms of population density, can be seen in terms of unit price. What else? Where else can you see more important to you regarding rates and ratios other than those two? I'm gonna give you one. Yesterday, so I'm a Shell, loyalty member. So yesterday, what's the date yesterday?
The 20th.
January 20th, right? They have like a 20 cent per gallon discount. So I did my full tank and stuff like that, right? So that's one of the things that's important to me as well is what?
Loyalty?
Loyalty, or in terms of rates and ratios, what's that? Well, first, the miles per gallon of my car,
Yeah.
right? The car that I'm driving right now is like what? 40 miles per gallon. So, yeah, pretty good. What about you guys?
If 21 to the gallon?
21 to a gallon. You see that? 21 miles to a gallon. And mine is 40 to a gallon. So, you're basically paying almost double of what I'm paying, right? In terms of the gallon.
What do you pay?
What car do you drive, Mr. Dill?
What do you pay? What do you mean?
Yeah, what do you, like, what's?
For gas?
Yes, for gas.
How much you pay?
Yeah, how much does it take usually to fill your tank?
Yeah.
Yeah, how big's your tank?
Oh, it's basically just a small,
So it's like 20
Car.
gallons?
Mine's $40.
Mine is
I would say like 30,
45.
25 to 30 bucks, right?
Never mind.
Oh, what about you?
Like mine.
It's like, okay, yeah. Yes, River. Race and ratios, how important is it to your life? I said miles per gallon is important, and basically why? Well, if I'm driving much
That's a lot of
and
gas.
gas is like pricey, I mean, it would matter to me the miles per gallon of my car. What about you, River?
This is just my musician brain firing off, but I thought of something that I thought would be kind of unique if you're a luthier, for example, someone who makes instruments. The distance from a fret to the bridge on an instrument in relation to the number of vibrations per second for a certain note that you want to be produced by that fret.
Okay, Doc.
What?
Calm
What?
down today. Hold on.
You just confused me.
We were talking
Yeah,
about
for
gas.
But yeah, fret and what? Bridge.
Yeah, and that would be, it would be more so the number of vibrations per second to the distance from the fret to the bridge. So like 12 inches would be, let's just say like 50 vibrations per second. And then if you move it further, it would go up in vibrations. And if you're at a certain point and it's not quite right, then the note's gonna sound off.
Wait, is it true when you say vibration per second, that's
Yeah, that's what
frequency?
determines the pitch of a note.
Is that the frequency?
Yeah.
Okay.
Stupid, but I hate it.
Oh, that's hertz, right? The
Yeah.
cycles per second.
hertz.
Yeah, hertz. All right, there we go. Well, thank you so much, guys, for your time with this one. After this, we're gonna work on measurements. All right. Thank you.
All right.